When we studied linear motion, we said that an object will remain at rest when the net force is equal to zero, or another way of stating that was when the forces were balanced. This correlated with Newton's first law, was one aspect of it. But what about this example? I have here something of a seesaw with two forces acting on it. One force is acting upward, one force is acting downward. Let's say that the total force or the net force acting on our object, which would include these two forces indicated with green arrows, as well as the force from the fulcrum, that's that triangle in the center, and the gravitational force. Let's say they all added up to equal zero. Would this object move at all? Well, to answer that question, we need to think about torques. The fulcrum is placed at the center, so it would not create any torque because it's at the axis of rotation. Similarly, the gravitational force wouldn't create a torque because it's located at that axis of rotation. So the R value in our torque equation would be zero. But these two forces that are depicted with green arrows would each cause a torque. And their torque would both be clockwise. Therefore, our seesaw would rotate, even though the net force acting on the seesaw is zero. So this brings up a new thing, that for an object to remain completely at rest, in other words, it's not moving linearly and not rotating, we call that being in equilibrium. Both the net force and the net torque must be zero. We'll apply these two important rules when we're analyzing objects that must remain at rest, both linearly and rotationally.